is Keith, as per the intro. I'm originally from Perth, Western Australia. So like most West Australians, I'm a little bit of a bogan. From WA, I went overseas, joined the army, went overseas with them, came back, went into tech, kind of hated it here in Australia in tech, to be frank. So I decided to go overseas and try to learn how to do stuff at scale and whatnot. I did that, came back, and have found Australia by and large similar to how I left it. Love Australia, not a fan of tech here, sorry. Also, to be frank, I'm really ignorant of what is DevOps, so I'm sorry. You've all paid money to paid money to come here to listen to someone who doesn't actually know what he's talking about. So what I will be talking about is that, basically. When I did come back to Australia about 2 years ago, I was working as a consultant, and I would rock on around Melbourne and a little bit of Sydney, and I'd hear a lot of talk about DevOps. So that's where I'm coming from in my knowledge of DevOps, is what I've seen here. So I've got a little bit of a rant here. Unfortunately, John was such an awesome speaker that he's kind of invalidated everything that I've got to say, so thanks, John. Awesome. So again, DevOps, what's the point? In my opinion, we're addicted to speed in technology, especially the business folks that have to interact with us technologists. They'll sit there and say, speed, it must be fast, it's fast, get it out the door, get it out the door, get it out the door. And then, of course, engineers sit there and say, but what about quality? They hear perfection when we say quality and tell you to shut up and deliver speed. So speed is something that I'm kind of scared of. So what I'm going to do is I'm going to tell you a story. Once upon a time, this is a bit of a story of woe, and then I'll go on to another happy story. So excuse the negativity, but it's to try and get a point across. I joined a company. We were awesome. I thought I was awesome. My mum agreed. We were very awesome. We were all about DevOps. We talked about DevOps. We said DevOps. So that meant that we knew DevOps, right? We did fast deployments. We championed it. We kept going around everyone, fast deployments, do fast stuff, fast. We're really about the speed. But we're also about faster recovery times. Like John was speaking about mean time to recovery and so on and so forth. We bragged about how fast we were about recovering from the things that we put into production really fast. So we could put it in there fast, we could pull it out fast, we were fast, and did I mention we were awesome at it? And we're great, we're cool, we thought we're cool anyway. Rapid change was something else we did, so we go from idea to reality. How do I get an idea out of someone's head and get it in front of a customer and have them laugh at my ideas? But we're rapid at that, we're really quick to do that, really fast, and we're awesome. We were lowering our costs, so we were saying, because we were so fast and so cheap, it was just great, you know, money was raining down, there was happiness everywhere, it was great. We basically DevOpsed everything. We DevOpsed my shoes with DevOps, they're red now, they were blue. We DevOpsed everything. I still didn't actually know what DevOps was, but I knew that we were doing stuff fast. Like, I was so friggin' fast. So what I've done, just a little bit that I left out of my intro, is I have been an engineer before. Now I'm post-technical. I talk about technology, unfortunately, for those who have to listen. But I've never been a graphics person, right? I've been a Unix engineer, a network engineer, a software engineer. I've done data science, where I hired mathematicians and statisticians to make me look smart. Again, coming from Perth, it was a tough job. But what I've done for you folks is I've created a little bit of an artistic, I think, animation to kind of describe my story of woe there. So we've got my laptop, and we've got production. The laptop was where all the magic would happen. I would write my code. It's poo code because it was Perl object-oriented code. I love Perl. Perl is great. Just don't try OO in Perl. And don't pull out Moose on me because I'll smack you with it. But my code was poo, right? But it was fast. It was very fast. We were so fast, we had uber fast build and deploy tools. They kind of looked like that rocket ship. I would get my poo code, I would throw it in a container, and then I would ship that off to production. Surprisingly though, I thought DevOps was supposed to be this silver bullet, right? But somehow, my poo code popped up into production and it was still poo. But it did get there fast. So, yeah, that's a bow on a turd. Basically, the best thing about my code now was that I was shipping at the speed of light. That shit went fast. And we did a lot of that. We were so awesome at being fast. I mentioned we're awesome, right? We're awesome. Mum used to send me text messages and stuff, say, Keith, you rock. But kids, friends, speed kills. I'm not talking about meth, even though I'm sure that does kill too. If you focus, like we did, on nothing but speed, you'll die. You won't die, like literally die, but, you know, your company probably should die at that stage. And what do I mean by that? I'll show you a demonstration of what speed did for us. Another one of my awesome animations here. So I've got my little rocket ship, I've got a container on it. John, it is Docker. Share prices won't go up because I'm buying it, but anyway. It was fast, but it was shit too. We didn't really build our build and deploy tools properly. We kind of just slapped it together. We were using things like Jenkins and all these other tools. But you know what? A tool is only as good as your usage of it, right? Like, I guarantee you, John, wherever you are, I could screw up Docker beyond recognition, right? Absolutely guaranteed. So it was so fast, and the faster we got, the more we did on our shit infrastructure, until eventually it blew up, and we had SSH left, which is a very reliable piece of software. I can't break it as much as I could everything else, and that's where we landed. So we had all of this brilliance, we had all of this awesomeness, we had all of this speed, and the better we got, the faster, sorry, not the better we got, because we didn't bother about that, we just got fast. The more we put on top of our stuff, the more pressure we put on it, and it blew up. And that was pretty much day 2 of our launch, and it kind of stayed that way. It's, the problem was, not that it made me sad, whilst it did, the problem wasn't technology, even though I love to blame technology. It was us. We sucked. We weren't that cool. We weren't that awesome. I don't read books. It shows. But others had, and we'd drunk the Kool-Aid, and we'd gone down the DevOps route, and we had text editors and Jenkins, and we were DevOps. But we were shit at it. We broke everything, basically, and everything blew up. So it wasn't cool. So that gets back to, that's the end of that story, thankfully. Quality at that place was a dirty word. If you ever said, boss, we didn't have a leader, we had a boss, could we just take breath and do some quality? Veins would pop out, vitriol would spew, engineers would cry and rock themselves gently in the corner. If you mention the word engineering and quality in the same sentence, you were doubly screwed, right? So you weren't allowed to do anything like that. So what is quality? I've got a lot of text on this slide, I'm sorry, but who would have known there's an ISO standard for this? Basically, blah, 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 but you've got a spec and ability to satisfy stated or implied needs. That's quality. Quality doesn't mean perfection, okay? Quality basically means, in a nutshell, it's good enough, right? The problem with good enough is, if your definition of good enough only has one variable, must be fast, then I'm sorry, it's going to be shit, right? Or poo. But it will be fast, right? So I believe that we should try to balance out speed and quality. Now, I know there was that triangle thing that was debunked in the other one with numbers from boffins and whatnot. As I said, I don't read. It's just my opinion. I think we should balance out speed and quality. I don't think John was saying don't do good, right? I don't think he was saying that. I'm just saying in my limited experience in DevOps, we focus on the one variable, and it's speed. So don't do that, is my opinion. So now I've got a happy story. Well, I think it's happy. It was happy for me anyway. So again, once upon a time, I worked at a company that was doing thousands of deployments per day. thousands. And that's not a fake number. There was about 50,000 of us doing thousands of things a day. Just joking, there wasn't 50,000 of us, but there was several hundreds of us who were doing hundreds of things per hour, thousands of things per day, and so on. My team that I was in at the time, at our peak, was 20 deployments per day, per person to production. I don't mean to staging, I don't mean to pre-prod or whatever you want to call those other environments. I mean, we as a team, we're averaging per person a day at our peak, 20 per day, right? But you're saying, hey, Keith, you just said speed sucks. There's a reason why this is a good story. We did get fast, but it was a byproduct of how we did things. It wasn't the goal. So I'm going to explain some of the things we had. This is not a technical talk, but I'm going to explain some of the things we had. We had a thing called environments, which are kind of like containers. Anyone here use RVM or CH Ruby or Homebrew and stuff like that? Not Homebrew, the Mac one, but Homebrew, the Perl thing. Basically, they're little environments in which you can stuff your software, have it as a little bounded context to run within. You can pull in all your dependencies as long as they're single language, right? So the RVM thing that Ruby has, you can put all your gems in there, but you can't get any dependencies outside of Ruby, right? So if you need ImageMagick or something like that installed on the operating system, you've got to own that yourself. We had this thing called environments, which would allow you to install all of your dependencies, no matter what language it was. So you could have Perl version 5.8 in there, you could have R6 or whatever it is, you have Ruby in a little environment, and then right next to it you have another environment with totally different versions of software. But when I say environments for the next few slides, just put the word container in there instead. We also deployed using packages. We didn't deploy just SCPing files over or FTPing them or what have you. We would create a package, kind of like an RPM or a Debian package or whatever the Windows folks use, and everything would be a package. What this did is it encouraged us to make sure our code would fit in a package, which kind of encouraged us to conform to good base engineering principles. We would do things like write libraries instead of monoliths. We would write things that had clean interfaces with small public interfaces and very big private interfaces. We had a simple configuration tool that would allow us to configure our packages and our environments and our deployments. I'm saying simple with air quotes because there was a bit of a learning curve, but if you take into account what we could achieve with this configuration, it was simple, okay? You could sit there and say what dependencies you had, what cross dependencies you had. You could handle dependency conflicts in there. You could do all sorts of wonderful stuff. So you couple the configurations with your packages, with your containers. We had the ability to build and test locally on your machine, on your desktop or a laptop or what have you. This was a really important thing. People, you've probably heard of pipeline-based deployments. Basically, your dev environment was part of the pipeline. It wasn't out of the picture. It wasn't something where, oh, my laptop's here, and then I push to that thing over there, and that's the beginning of the pipeline. Your laptop was the beginning of the pipeline, which is just ranted on the pipeline bits. So here's a really, really bad diagram of what I'm talking about. It's not very, detailed, and there's a lot of working parts that aren't in there, and there's a lot of stuff that goes into it, but basically you go from your laptop, you push your code out, it ends up getting built, gets thrown up on a beta server. On that beta server, we had some automated tests and we had manual tests. This was our first go at pipelines in the teams that I was in. What would happen is the test would pass or fail, and you would determine that as a human by looking at a screen, and then you would handle it. You would roll it back and try to roll over it again. If you liked what you saw, you'd click a button, it would be manually promoted to the Gamma environment. Gamma would be just more automated tests, right? These were automated, yeah? But again, a human would go in, because we didn't have a lot of confidence in what we were doing, and you would determine whether it was good or bad. Bad, roll back. Good, roll forward by clicking a button. It ends up in prod. Prod, we had continuously monitored, right? So what I mean by continuous monitoring is we weren't just monitoring periodically things like your CPU and your memory. We were monitoring business metrics. So I'll go off on a little tangent if I can on that. There was a big earthquake in Japan in 2011. Nuclear reactors were melting down and whatnot. During the earthquake, which lasted for about 7 minutes, I think it was, we were all under tables. People say the Japanese were so calm in that. They weren't. People were screaming, they were yelling, they were crying, they were in fear of their life. And my pager went off about 3 minutes into the into the earthquake. So there I am under the table with my pager, and all these people from around the world are on a call. The call had been automatically set up by the continuously monitoring thing. So no humans had set this up. The machines had said, we're in trouble. Set up a call. We all get paged in. The reason was because sales had gone down a fraction of a standard deviation from where they should be for that given time of day, for that kind of day, right? So it was a business metric for which we were getting people out of bed. It wasn't because the CPU was busy. Like, you're paying for the CPU, let it be busy. It was because some business thing had happened. So we're not just monitoring CPUs and stuff, we're monitoring business outcomes as well. The next version of what we did is we cut out gamma and we had alpha beta with an auto promotion step to prod. So what we'd have is, if you notice, we had manual tests before, everything was automated, right? So you push some code, beta, it's all automated. If it's green, just goes to prod, right? During the prod deployment, now you notice we're doing continuous testing as well as continuous monitoring, right? So we're running tests in production constantly. So say you've got 10 servers, you do a rolling deployment, you might deploy to one of them. If you notice a problem, you kill the deployment, you roll back that puppy and you're all good. You don't have to wait for the whole deployment to finish, right? You can roll it out incrementally and kill it halfway through. It auto rolled back and then it would also notify us to say something's gone wrong. So that was good, we're happy with that. Then we got Brave, and this wasn't for all of our services. This was just for some of the services. It goes straight from alpha straight to prod. You type git push and that code is going to prod, right? There's nothing in between, right? Besides the fact that it gets built into a package and then deployed. But you literally, your interface to production was git push. And I'm talking like deploying to 1,000 servers around the world with a git push command. And that was it. If anything broke during the deployment, it would auto roll back, you get notified and you go, oh, that sucks, and you'd roll over it, right? Or roll back, it's already rolled back, sorry. Before, when I said your laptop is part of the pipeline, when I did a code review, I just click a button. Anyone in the company could then access the code on my laptop via a web interface and do the code review before I've even pushed it off the box. I could invite a business partner to look at the code, look at the output of my code on my desktop and say, that Keith, that sucks, there's no way you're pushing that, or yes, I like it, off you go. That's why we had no other environments, right? By the way, we didn't call this DevOps. We just called it engineering. So this is the other thing we had was like at a set time of the day, on a certain day of the week, for us it was typically about 3 or 4 in the morning on a Tuesday, our software would automatically build, again, bringing in all of the dependencies and all the new dependencies and rebuild off that. It wouldn't be our code, it would be just bringing in all the new dependencies and stuff. So say you had a dependency on ImageMagick 2.4, well, at 3 in the morning on a Tuesday, it would bring in ImageMagick 2.5, build, and deploy to production. No humans, no one awake, everyone asleep, no panic, no nothing. Because it was being continuously tested, it was being continuously monitored, if the deployment failed, it would roll back in the morning, you'd get to work, and you'd see a little message saying, your auto build deploy failed last night, you've got to kind of clean it up. So what did this do? As I said, git push, you're done. It was very simple. The key thing was our tools became simple, they were reliable, and they were stable. So we used them, funny enough. But what it did do, we didn't actually get faster, right? Companies like this don't have a team that slows the rotation of the Earth so they can have a 26-hour day while the rest of us slobs get a 24-hour day. We didn't get faster. These didn't type any faster. I didn't actually get faster in any way, shape, or form as an actual engineer typing, like line by line. What I did get, though, was more time focusing on doing better in my text editor. Does that make sense? Yeah. Because I had more time, I could actually concentrate on the quality and meeting the spec. And then when I went to git push, that's when it was fast. But the reason why that was fast was because that was also quality as well. And it was built by people way smarter than I was. So I did live happily ever after, thereafter. These stories are out of order, by the way. So, where does that leave us? Why DevOps? I think John did a great job. I now understand DevOps more. I probably should have read a book before I came to the conference. But I get it, right? So, to answer the question in my version of why DevOps, I believe that we engineers, we humans, enjoy to deliver quality outcomes. I know it used to float my boat to see someone benefiting from my software, whether it was another engineer that was consuming a library that I'd written, or it was a customer enjoying some software I wrote, or not. But we like to do it, right? That's part of what we do. We also like to continually improve. Engineers are a sad mob, typically. You find an engineer and you say, tell me about your favorite technology. And they'll rant on how great it is, but then they'll spend the next 3 hours telling you about all the broken bits of it. So we're always looking for improvements. We always, actually, if you've got a good team, which I bet all of you do, if you treat them as adults and empower them, you'll find that they actually do want to balance out the quality, the agility, and the speed. They don't want to procrastinate and have deployment anxiety and so on and so forth, but they do want to do a good job. And they do want to get stuff out there fast. So empower your folks, let them do that, and let them actually spend time. When an engineer says to management, can I pay down some tech debt? Don't spit at them and kick them to the floor. Let them do that, right? Let them fix broken things because they will get better and the side effect will be speed. So what I'm trying to say is don't just concentrate on speed. Again, let them build tools that are simple, powerful, and reliable. If you've got a tool like in my first story that wasn't reliable, it wasn't simple, and it wasn't powerful, it will blow up and you won't get the side effects of speed. Anyone here suffering from ITIL? Yeah? Yeah, ITILitis? ITILitis is a scorn. The spirit of ITIL is great, the implementation is woeful. It's all about blame, redirection, and just finding out who approved this change. So eventually you get a database change and some reason finance is approving a database change. But anyway, they're not there when it fails though. But anyway, again, speed kills. It does. It'll kill a company if all you focus on is speed. Now I'm not saying don't care about speed. What I'm saying is do the right thing and speed as a side effect will happen. So I'd ask you to do a bit of a thought experiment. We've got a couple of minutes. Imagine what engineers could do if they could focus. Wow. If they could focus on helping others. If they could focus on helping others with code. If they could focus. Like really, wouldn't that be awesome? As opposed to having them just churning out code at the speed of 1,000 startled gazelles, right? You want them to focus on the right thing. I kind of ranted at my mate Shiva up there before. You hire a natural language processing engineer, and then you say, because you want to build the world's best relevance engine, and then you say, there's Doc, and I go dick around with Ubuntu. Why? You want that person to focus on the thing that matters for your company. It'd be awesome to do so. Imagine what engineers could do if they could roll out changes quickly and roll them back quickly. It'd give them more time to focus on things. Yeah? Imagine what engineers could do if they could just do their jobs, basically, and if they could focus. If we could empower our engineers, if we could encourage them to empathize with the folks that are going to consume their code, my catch cry is TDD, and it's not test-driven development, it's team-driven development. They realize that I'm writing software for future Keith, or I'm writing software for another engineer to consume his library, or I'm actually writing software for a customer. In the end, you're writing software for someone else, not yourself. By the way, engineers in the room, you know when you write code, 6 weeks later you read it back and you go, what was I thinking, this is crap. To go to one of the points that John spoke about lean, I did work in warehousing and supply chain for a long time, I love lean, it's all about removing waste. So I recommend hate your code as you write it. Right? That's what I do. I'm sitting there going, I don't know what the fuck I'm doing as I'm writing my code, right? And if I do that, I'm serious, half serious, write your code thinking this code is crap, this is poo code, this is rubbish code, as you're writing it, and you'll be improving it as you write it. I think, that's what I try to do anyway. So again, speed kills, let your engineers concentrate on quality, let them concentrate on empathy, or encourage that if they don't have it, let them focus, and let them take responsibility, okay? If you don't do any of those, who really cares if you can deploy fast? I mean, really, you're going to be deploying code that's not written for anyone else except for the engineer because they wanted to try out this new cool tool, which I think is Elixir now, isn't it? Anyone? Any millennials in the room? I'll tell you what to. I think it's Elixir. So anyway, or something, right? You want them to focus on problems for your customers. You want them to focus on quality outcomes for themselves and for their peers and for their customers. That's basically what I have. That's the end of my talk. If you've got any questions, I think we've got time. I will try to answer them or not. Thank you.